Digital fabrication allows designers to easily materialize shapes and objects by implementing their virtual designs. But compared with traditional craft, digital fabrication still lacks the intimacy between a maker and the raw material, a process that inherently allows creative decisions during fabrication and results in a unique creation. To that end, we developed the 3D, a handheld digital milling device that is monitored by a computer, but still preserves the maker's gestural freedom. The computer serves as a guide, but the user is free to ignore it. At times, when the model is at risk, the tool prevents a crucial mistake by stopping the spindle. The tool contains a custom milling mechanism built on top of a long shaft connected to a DC motor. A three-dimensional bearing mechanism is located underneath the handle above a titanium shaft. 3 servo motors determine the shaft's position. An electronic circuit controls both the shaft movement and the spindle speed. In addition, a pressure sensor on the handle allows for overriding of the computer. The working environment contains a magnetic motion tracking system, a control laptop, and software distributed over the laptop and the tool. The computer intervenes only when the milling beat approaches the surface of a 3D virtual model. In such a case, it slows down the spindle speed up to a complete stop on the surface. The user may penetrate the model using the control button. The 3D allows unskilled makers to be involved in digital fabrication of personal artifacts which are produced in synergy of man and machine. Using the 3D, there are 3 interaction modes: static model, non-rigid model, and an autonomous mode of tool operation. In fabricating static CAD models, the computer only prevents the user from damaging the model. By overriding the computer with a button, the user eliminates the digital control. In addition to leaving parts unfinished, here the maker can intentionally damage the model, working around or inside the virtual shape. This process results in a unique texture and singular aesthetics of the work. Unlike a mechanical toolpath, the manual one, which is a product of the maker's dexterity and patience, never repeats itself and renders a unique signature. In the second interaction mode, the computer interactively modifies the model responding to user actions. One way to achieve this is by shape deformation. For example, here the user penetrated the giraffe model. The computer responded in deforming the shape to create a new one. Alternatively, here we used a database search process of an alien model. Starting with a given material block, the user freely removes material while the computer proposes new positions, searching the large collection of poses. After finding a position, the computer fine-tunes a pre-stored pose to fit it into the remaining material. After an interactive process, the work converges into a final unique artifact. In the last mode, the computer can operate independently of the user for tasks such as automatic milling in a predefined area. A useful application is automatic texture rendering, as presented in our teddy bear example. Together, these 3 modes span a new collaborative space where both human and computer contribute to the final product. We wish the 3D to enable creative work in a domain yet unexplored, a new hybrid territory of artifacts produced in synergy of machine and men, fusing automated production with human subjectivity.